Hello friends and welcome back. So up to now we completed our syllabus of diode circuits. So this whole topic is completed with the get previous year questions also. Now what I am doing is I am going into transistor circuits. If you see transistor circuits in gate syllabus we have two. One is BJT, one is FET. First thing is biasing of BJT and FET. Next thing is how we will use BJT and FET as an amplifier circuit. So these are the two things which are there in the gate syllabus. So I will discuss that. What I will do is first I will discuss the basic of transistor. Next I will go to BJT. Next I will go to FET and I will discuss their biasing. Don't get afraid by listening to the word biasing guys, it is very easy. And similarly FET biasing. After this I will tell how we will use these two transistors BJT and FET as an amplifier. Is this okay guys? Let's proceed. So first, what is an transistor? So guys, if I consider a transistor here, I am applying a signal to the transistor. Let me call this as input. So we will take output. So what the transistor will do is, it will change the properties of the input signal. Like it can increase the magnitude of input signal, it can decrease the magnitude of input signal, and it can do anything. To change the properties of input signal, we are using a transistor. So this is the basic definition of transistor, and we are having two types of transistors. They are bipolar transistor and unipolar transistor. So why the names are given is, sometimes in state exam they will ask why it is called as a bipolar transistor. So here conduction is due to both electrons and holes guys in bipolar transistor, while in unipolar transistor conduction is only due to either electrons or holes. Both will not conduct here, either electrons will conduct or holes will conduct. But in bipolar transistor both electron and holes both will conduct. So that's why the name bipolar is given. That's why the name unipolar is given. So bipolar devices are current control devices. Remember this. While unipolar devices are voltage control devices. An example for bipolar device is BJT guys. And unipolar device is FET. MOSFET, JFET, we'll discuss about that. So now tell me guys, is BJT a current control device or voltage control device? Yes, it is a current control device. Why? BJT is bipolar device. In bipolar, conduction is due to both electrons and holes, and it is a current control device. Next, is FET a current controlled or voltage controlled? Right, it's a voltage control device. And conduction is only due to electrons or due to holes, and it is a unipolar device. So this is the basic difference between BJT and FET guys. Hope you got my point. BJT is bipolar device, FET is unipolar device. BJT is current controlled and FET is voltage controlled. BJT conduction is due to both electrons and holes. In FET, conduction is due to either electrons or holes. So is this okay guys? Now what I will do is, first I will discuss the basics of BJT and I will discuss the biasing of BJT. So let's proceed. So basics of BJT. In BJT you will have two kinds guys. First one is NPN, next one is PNP. NPN is nothing but P-type is sandwiched between two N-types. This is NPN. And PNP is N-type is sandwiched between two P-types. This is PNP transistor. So first we will discuss about NPN transistor guys. So see here. This is the N-type. This is the N-type. This is the P-type. P-type is sandwiched between two N-type layers. So this is called as NPN transistor. So this is called as collector terminal. This is called as emitter terminal. And this is called as base terminal. If you see the equivalent representation, it will be like this. It is the equivalent symbol of BJT. So this is the base, this is the collector, this is the emitter. So this direction indicates the flow of current. So here direction is like this. So current flow from IC, IB, and they combine at IE. So this direction indicates the flow of current. So it is a symbol for NPN transistor. In NPN transistor, current flows from IC, IB, and they combine at IE. So current flows from IC, IB to IE. In NPN transistor, if you see PNP transistor, see guys, this is the PNP transistor. So N type is sandwiched between the two P types. If you see here, the arrow mark is inwards. That is, current is flowing inside from IE, IB, IC. So this is the direction of flow of current in PNP transistor. So this is the major difference between NPN transistor and PNP transistor while considering the problem, guys. Next, what is emitter? The name itself indicates emitter emits the electrons or emits the charged particles. So since it should emit the charged particles, it is heavily doped. Why it is heavily doped, guys? It should emit the charged particle, so it is heavily doped. Next, while coming to collector, it should collect the charged particles, so it should have more space, guys. So collector is very big in size and it is moderately doped. So collector is completed, emitter is completed. What will the base do? Base will control the current flow, guys. That's why it is called as current control device. So since base is used only for controlling, it should be very lightly doped, because it should not participate in the current flow. In practical conditions it will participate, but it should not participate. So it is very lightly doped, very lightly doped. This is called as base, guys. So these are the function of collector, emitter and base. I am repeating again. Emitter is heavily doped, collector is moderately doped, base is slightly doped. If you observe this, guys, there are two junctions here. Since this is p type, this is n type. One junction is formed. This is p type, this is n type. Another junction is also formed. So I am naming this as collector junction. I am naming this as emitter junction. So this is the base, guys. It is the emitter junction. This is the collector junction. Now what I am doing is, if you observe here, this is a p type, this is a n type. So I am drawing a diode like this. This is p type, this is n type. Next, while seeing from this side, this is p type, this is n type. So I am also drawing a diode like this. This is collector, this is emitter, this is base, guys. So it is just for your understanding, guys. Really, transistor is not a combination of two diodes, it is a separate device. So just for understanding I am drawing this. If someone asks you, is transistor a combination of two diodes? Because PN is there, PN is there. Since it is two diodes, is it true? No, guys, it is not true. This construction is different. Just for our understanding, I am representing as two diodes. So if you see these two diodes here, I can apply any voltage here and any voltage here. So by applying these three voltages, I can make this diode either forward bias or reverse bias, guys. Similarly, by applying voltages here and here, I can make this diode either forward bias or reverse bias. Guys, what does this diode represent? Emitter junction. What does this diode represent? Collector junction. Remember that. So see, if I apply 3 volt here, some 2 volt here, and I am applying 1 volt here. So what is the condition of this diode, guys? 3 is connected here, 2 is connected to here. So P type voltage is greater than N type voltage. It is in forward bias condition. What is the condition of this diode, guys? It is in forward bias condition because p-type voltage is greater than n-type voltage. So if you observe here, this diode is equivalent to this emitter junction and collector junction, guys. So this is in forward bias, this is in forward bias. So by applying different kinds of voltages, I can operate this diode in forward bias and reverse bias. Similarly, this diode also in forward bias and reverse bias. So based on this, we have 4 characteristics, guys. I will show you. So friends, based on the condition of these diodes, we are getting 4 regions of operation. Let us see what they are. J represents the emitter junction, JC represents the capacitor junction, this one and this one. So transistor is not made of 2 diodes, guys. For our analysis purpose, we are representing it like this. First, if JE is forward biased, JC is forward biased. So we are applying base collector and emitter voltages in such a way that this is forward biased, this is also forward biased. Example is some 5 volt, 2 volt, 3 volt. So JC is in forward bias condition, JE also in forward bias condition. So it acts in saturation region, that is on switch. So what are the characteristics of on switch, guys? If there is a switch, if we turn on this switch, the current flowing through the switch will be maximum and the voltage across switch will be nearly equal to 0 or some 0.2 volt, very less. So these are the characteristics of on switch, guys. So the thing is, we can use diode as an on switch directly, right? If we apply more voltage here, if we keep diode in non-state, it will act as an on switch. So for this much setup is not required. These 3 batteries to keep these 2 junctions in on position and a transistor, this much setup is not required. A single diode can do the operation of a switch. So it is possible by using transistor, but not recommended. Why? It can be done by using only one diode. Next, reverse bias and reverse bias. So if 2 junctions are in reverse bias, it will act in cutoff region. Example, I am applying 2 volt here, 5 volt, 4 volt. See, now this is in reverse bias condition, this is also in reverse bias condition. Its operating region is cutoff, that is off switch. If you observe off switch, guys, I will be 0 and voltage across switch will be maximum. So these are the conditions of off switch. But for off switch, again diode can do that. If you apply reverse bias across diode, it will act as an off switch. Again this much setup is not required. So this is also not recommended. But guys, if you see here, when it is acting in saturation region, it is on switch. So VCE will be nearly equal to 0.2, IC will be maximum. We have already seen the conditions here. So VCE will be very low, IC will be maximum. That is the conditions of on switch. While coming to off switch, VCE will be maximum, IC will be nearly equal to 0. Not nearly, it will be equal to 0, but VCE will be maximum. So these are the conditions of off switch we have seen here. Next, if you see the third condition, if JE is forward biased, JC is reverse biased, it will act in active region and it will act as an amplifier. So example is, this should be forward biased. So I am applying 5 volt here, some 2 volt here. This should be reverse biased. So I am applying 7 volt here. If you observe this, guys, this is in forward biased, this is in reverse bias condition. It is acting as an amplifier. So could you tell me a device which acts as an amplifier? No, it is the property of the BJT only. So for this purpose we use the BJT. For on switch, off switch, we can use any other circuit, that is BJT is not recommended. But for amplification action, only BJT can do that. No other circuit can perform this amplification action, only BJT can do that. So we are interested in this region of operation. So this is the purpose we will use BJT. Why? Because no other device can amplify a signal. Only BJT can do that. That too in active region. What is active region? JE should be in forward biased. This should be in reverse biased. That is active region. Next, the last region is what is JE. JE should be in reverse bias. JC should be in forward bias. So this condition, it should be forward biased. It should be reverse biased. So since it should be reverse biased, I am applying 7 volt here. It should be forward biased. I am applying 2 volt here. So under this condition, it will act as an attenuator circuit. So what is attenuator, guys? It just attenuates the signal. If you apply 10 volt here, I am taking 5 kilo ohm, 5 kilo ohm. What is the voltage you are getting? 5 volt. See, simply two resistors are doing the attenuation of the signal. So resistors are very cheap, guys, when compared to BJT. So attenuation can be done by small resistors. For this BJT, then this much setup is not required. So this is also not advisable. So what I am concluding is, these three operations can be performed by any other circuit very cheaply. So we are not interested to perform these three operations by using BJT, guys. We can perform, but it is not advisable because we can perform by using other circuits very cheaply. This 2-bar diode, this by 2 resistors. So BJT is not advisable. But this operation can only be performed by BJT. So now you got in clarity, guys. Now I am introducing a term biasing. So what is biasing? You know one thing, we already read biasing. Applying the DC voltages to keep these junctions in forward bias or reverse bias is called as biasing. That's it, guys. Applying the DC voltages to keep the junction in either forward or reverse bias condition is called as biasing, guys. So since we are applying DC voltage and the currents which are flowing are DC currents, the biasing is called as DC biasing. So what is our next topic? BJT as an amplifier. For BJT as an amplifier, what we should do? We should keep JE in forward biased and JC in reverse bias condition. Then only we can use this as amplifier. If these conditions are not satisfied, then we cannot use BJT as an amplifier. So what is the condition, guys? This should be in forward bias condition. This should be in reverse bias condition. Then only we can use BJT as an amplifier. So this is the main basic point. So for this, we are applying voltages like it should be in forward bias. I am applying 3 volt here. I am applying 1 volt here. This should be in reverse bias. I am applying 5 volt here. So we are applying some DC voltages to keep these diodes in reverse bias and forward bias. That is called as biasing. So hope you got my point, guys. Since we are applying DC voltages and currents which are flowing are DC, it is also called as DC biasing. So I am telling for the last time, what is biasing, guys? Applying DC voltages to keep the junctions in some condition like forward bias or reverse bias. For amplification action, we require forward bias and reverse bias. For attaining this, we are applying some DC voltages. It is called as biasing. So now you got clarity what is a biasing and how we will use BJT as an amplifier. That means in which region we will use BJT as an amplifier. You got a clarity, right? So guys, I have given 4 circuits here and I have given the region of operation. Now what is your duty is, you should bias these circuits according to the regions given. So do with me. What is first region, guys? Saturation. For saturation, this should be in forward biased and this also should be in forward biased. So remember the equivalent circuit, guys, this one. Remember this circuit. It will be very easy for you. So this should be in forward bias, this should be in forward bias for saturation. So let us bias. For this to be in forward bias, I am applying some 2 volt here and 1 volt here. It is in forward biased. For this to be in forward biased, I am also applying 1 volt here. So we did biasing to this circuit and we kept that in saturation region. Good. Now cutoff. For this to be in cutoff, it should be in reverse bias. It should be in reverse bias. For reverse bias, base voltage should be greater than emitter voltage. So I'm applying 5 volt here. Sorry, for reverse bias, base voltage should be less than emitter voltage. I'm applying 2 volt here. I'm applying 5 volt here. It is in reverse bias. I'm applying 4 volt here. Your wish, guys. Our main aim is to keep this in reverse bias. So we did biasing to this circuit also, and we kept that in cutoff region. Now keep this in active region. It should be in forward bias. It should be in reverse bias. Do biasing, guys, firstly. So it should be in forward bias. I'm applying some 3 volt here, 1 volt here. It should be in reverse bias, so applying 5 volt here. Next, do bias to the last circuit also, inverse active region. So this should be in forward biased, this should be reverse biased. So this should be in reverse bias. I'm applying some 2 volt here and 5 volt here. This should be in forward biased. I'm applying 1 volt here. So this is the biasing, guys. We did the biasing and we kept our BJT in these 4 regions. So moving ahead. So quickly solve these 3 questions, guys. They are very easy. See here -3 is applied. Here 0 is applied. So since this is a equivalent circuit, see here minus is applied, here 0 is applied. So it will be in reverse bias condition. And here 5 is applied. So here negative is applied, here positive is applied. It will also be in reverse bias condition. So this acts as which circuit, guys? Both are in reverse bias, cutoff region. Otherwise off switch. If you see here 2 is applied, here 0 is applied. So it is in forward bias condition. Every time you should not draw this circuit, guys. Just see from here. Analyze by using this circuit only. Here 2 is applied, here -3 is applied. So what is the region, guys? It is also in forward bias. If this voltage is greater than this voltage, forward bias. If this voltage is greater than this voltage, forward biased. So it is base, it is collector, it is emitter. If VB is greater than VE, JE is forward biased. If VB is greater than VC, JC is forward biased. Now remember this, guys. See here which voltage is greater. If this is greater, that is forward biased. Similarly here also. If you see here 0 is greater than -3, so it is reverse biased. And 5 is greater than -3, so it is reverse biased. If you see in this circuit 2 is greater than 0, so it is forward biased. 2 is greater than -3, so it is also forward biased. And if you see this circuit, many people will make mistake here because I reversed the terminals. It is collector, it is base, it is emitter. But I have drawn this in reverse manner. This is the emitter. This is the base. This is the collector. Now see, base voltage is -2, emitter voltage is -5, and collector voltage is 0. If you observe this junction, collector voltage is greater than base voltage, so it is in reverse bias. And here base voltage is greater than emitter voltage, so it is in forward bias. See, our JE region is in forward biased and JC is in reverse biased, so it is in active region. Similarly here both are in forward biased, so it is acts as on switch. And saturation region. So is this okay, guys? So guys, if you observe here, leave about these 3 circuits because these 3 are not important. The important one is this one. To keep this in active region, this should be forward biased, this should be reverse biased. So I'm applying some 2 volt here, 1 volt here, and 3 volt here. So for using BJT as an amplifier, you should keep in active region, right? For keeping this in active region, we should apply 3 voltages here. Indirectly 3 voltages means 3 DC batteries. So if you want to use an BJT as an amplifier, you require BJT plus 3 DC batteries. Is this advisable, guys? See, if you want to buy a BJT, you will buy an BJT, and if you want to use it an amplifier, and you should buy another 3 DC batteries also. So this is not advisable. We should acquire the active region by using only one battery. So we should not use 3 batteries to acquire the active region and use for amplification purpose. We should use only one battery, and we should acquire the active region, and we should use for amplification. So this is our basic idea, guys. Now what I am doing is I will show you a circuit. So guys, if you see this circuit, we are using only one battery here. So now what we will do is we will check the region of operation of this transistor. This is VB, this is VC, this is VA. How will you check? Find out VB, find out VC, and find out VA. So by using this circuit, we are using only one battery, guys. See. So how will you find out VB? If you observe here, this acts as an diode. So there will be threshold voltage here in reverse direction. And this is IB. Similarly, this is IC. I haven't told you the current relation, guys. Just I will tell you. Remember for now. Afterwards, I will explain. IC equal to IB plus IC. Sorry, IA equal to IB plus IC. And IC equal to beta IB, guys. Just for now, remember these two equations, where beta is called as current gain. So now this is an homework for you guys. Find out in which region the BJT is operating. So how will you find out? First find out IB. What is IB, guys? 20 minus 0.7 by 200 kilo. 20 minus 0.7 by 200 kilo. After finding IB, find out VB, guys. What is VB? 20 minus 200 kilo into IB. So now you got VB value also. Next find IC. What is IC? Beta IB. Take beta as 100, guys. For now I will explain what is beta afterwards. Take beta as 100. So after finding IC value, find out VC also. 20 minus 1 kilo into IC. KVL in this loop. This is VC. Guys, now you got VB value, VC value, VE value. So by checking these three values, mention in the comment section whether this is operating in saturation, cutoff, or active region, or inverse active region. So do this problem, guys, and mention in the comment section what is the region of operation of this circuit. So I am stopping this lecture for now. In the next lecture we will discuss biasing circuits like fixed bias, collector to base bias, and voltage divider bias. So we'll discuss what are these biasing circuits and we will discuss them. And you know one thing, this is the fixed bias circuit. Very simple, guys. Nothing to worry. There are many shortcuts with me. I will give you every information. So guys, if you are really learning something from my channel, do subscribe to my channel, guys. I will know that someone is learning something from my channel. If you are not subscribing to my channel, I won't know that. So what will happen is, I will think no one is learning from my channel. Why should I do videos? That is correct now, guys. If no one is learning from my channel, there is no need of doing videos. So if you are learning something, please subscribe to my channel so that I will know you are learning. And it really motivates to me do more videos, guys. So this is for now. Meet you in next lecture. Thank you.